Hello friend, welcome to ashatech.com. Today I'm going to solve a differential equation and we are going to find out that this one has got a characteristic equation with a complex root. Now, solve the differential equation. The x squared dt squared plus 6 dx dt plus 10x is equal to 0. This is telling us that the function x varies with the time according to this differential equation. Given the boundary conditions or initial conditions, x is equal to 0 and the x dt is equal to 1 when t is equal to 0. So let us look at the solution. Using the d operator, it means this differential equation can also be written as d squared plus 6d plus 10 of x is equal to 0. So the characteristic equation becomes m squared plus 6m plus 10 is equal to 0. So now we're using the equation x equal to, since we have used the m is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So m is equal to minus 6 plus or minus, because b is 6, then square root of b squared, which is 6 squared is 36, minus 4 times a, the coefficient here is 1, times 10, which is also a constant c, and it is 10 here. So divide by 2 times 1 because a is equal to 1. Now when we simplify, we realize m is equal to plus, it is actually equal to minus plus or minus j. So that means my m1 is equal to minus 3 plus j, and m2 is equal to minus 3 minus j. Therefore, alpha is equal to minus 3 and beta is equal to 1, because this is written as m is equal to alpha plus or minus j beta. So if m is equal to minus 3 plus or minus j, then our m1 becomes that, m2 becomes that, and therefore alpha is that and beta is equal to 1. So the general solution, if we have complex roots, becomes y is equal to exponential alpha x into c1 cos beta x plus c2 sine beta x. But now, since we have x as the one which is the dependent variable, with the time being an independent variable, it means x is equal to exponential of negative 3t into c1 cos t plus c2 sine t, because we have said beta is equal to 1 and alpha is equal to negative 3. So it is given that when t is equal to 0, x is equal to 0, and we have found out that the x dt is equal to a particular figure. So let us put in our values. When x is 0, 0 is equal to also t is equal to 0, exponential of negative 3 of 0. So c1 cos 0 is 1 times c1 plus c2 sine t, because we know sine 0 is equal to 0. Therefore, when we substitute it in, c1 will finally equal to 0. So let us differentiate the x dt. The x dt is equal to negative c1 sine t exponential of negative 3t minus 3 negative exponential negative 3t c1 cos t, because this that we are differentiating gives us the product rule, so that you have v d of dx of vu will equal to u dv dx plus v du dx. So that means If we use the product rule, we shall come up with negative c1 sin t exponential of negative 3t minus 3 exponential negative 3t c1 cos t plus c2 cos t exponential negative 3t minus 3 exponential negative 3t sin t times c2. So now, if we correct the like terms together, we find that we have exponential negative 3t sin t times negative 3 c2 minus c1 plus exponential negative 3t cos t of c2 minus 3c1. So when t is equal to 0, the x dt is equal to 1. So let us put in our values. The x dt is 1. Let us put t 0. So this becomes 0. The whole of this becomes 0. And we remain with something like this is also to power 0 and becomes 1, cos 0 is 1 into c2 minus 3c1. 3c1 is 0 because c1 is 0. I said this is 0. This becomes 0. If that is, this becomes 1. This also becomes 1. This becomes 1. And therefore, we shall remain with 1 equal to 0 plus 1 and c2 is equal to 1. The solution therefore becomes, if I substitute in the other in my equation, x equal to exponential of negative 3t into c1 cos t plus c2 sin t. So if this is 0, I remain with this c2 which is 1. So my equation becomes x equal to exponential of negative 3t sin t. Thank you so much for following. See us in the next lecture.